All right, so welcome to Intro to Astro. I am David Collins, and I'll be your teacher for this semester. So today we're going to go through the syllabus and talk about what to expect from class. Okay, so I am David Collins. Office hours are going to be office hours will be Thursday at 2:30 to 3:30. Did everybody get a voter? All right. Office hours will be 2:30. You can say that. I'll give them to you. And somebody else. Yeah. Did anybody else missing one? I'll explain what we do with these in a second. This is a way for me to have a conversation with you guys, everybody at once, because I can talk. I'm really good at talking. I can talk all day, and nobody would get anything out of it if I didn't stop once in a while to listen to how you guys are doing. That's what these are for, so you don't need to think about it too much for now. Okay, my email address is DC Collins. There's 2 C's. Don't screw that up. And class is now, clearly. So let's see. My background is in theoretical astrophysics, so I study, I make computer models of stars and galaxies forming, yeah, that's what I like doing. I got my PhD in 2009 from San Diego, and I did, so I lived there for a couple of years, and then I did a postdoc at Los Alamos National Lab, which is in New Mexico. And then I came here since in 2013, so I've been teaching astrophysics at FSU for about 10 years now. And I really believe that you got to do all the work. I really can't teach very much. I can tell you the things that I think that you ought to go learn, but that's kind of the center of my teaching philosophy, is making you guys do stuff. And this is my first time teaching this class. I've taught several other classes here before, but this is my first time teaching Intro to Astro. So there's going to be things that I don't get out in time and glitches and stuff. So I appreciate your patience going forward. For the most part, it should be smooth. I'm pretty well organized this year. Okay, prerequisites are 2048 and 2049, and the first year calculus. And if you're short on those, come talk to me. I need you to have all of those things. So those are necessary. This is a physics class, and I treat it as such. So the book is Carolyn Osley. Does everybody have a copy of the book? Does anybody? I have a copy of the book. Raise your hand. I don't have a copy of the book yet. Hey, sweet, that's everybody. This is the book. Go get a copy of this book. There's a reading due tomorrow night, so Amazon's going to be slow. I'll see if I can scare up a digital copy and stick it on Canvas. If not, you guys can scare up digital copies just as well as I can. Don't steal. But not having a physical copy shouldn't be a barrier for you right now, but you should get the book shortly. We're going to go through a good chunk of the book, so there's going to be a lot of reading. I assign a lot of readings, mostly because it's way better for you to show up to class already having a basic idea of what I'm going to say, because it's all hard. I'm going to be straight with you. This isn't an easy class. So it's all difficult. So if you see it before you get to class, then I can actually explain it. And then that's how this is going to work out best, is if you have an idea, okay, today we're going to talk about Kepler's laws, and I didn't understand a single thing about those guys, but then I can come explain it and shore up the background. But having you guys do the readings first is important. Every assignment that I have is due at midnight the day before class. So as I said before, sometimes I'm a little spacey. Sometimes I'll put the due date on class. I mean midnight the day before. I try to make sure that it's clear that way in Canvas. But that's the way everything always is. That way I can show up, start my day, and I start grading or looking at the readings or whatever. So the first thing I like to do is look at what you guys have given me. So they're formally due at midnight. I don't actually check until 8 o'clock. So, but don't stay up all night doing the homework. Practice good sleep hygiene. It's good for you. So that's minor. One question that I will always ask is, how long did this assignment or reading or whatnot take you? I'm not going to ask on the final, because I'll watch you leave, but because I can see you. But when you're doing the homeworks or doing the readings, I like to know how long it takes you. And I'm not judging you, I'm judging the assignment. So I'm doing this now. I've been doing this, I do this for every class that I teach. I always ask how long things take. It's a really useful metric for me about how well the problems, the readings, the assignments, or whatever are sticking with the students. So your individual value is interesting to me, but I also know that you're a particular person. You've measured it in a certain way. You've estimated the time it took you in a certain way. I'm not really judging how long the readings took you, but the distribution is what I'm looking for. So if everybody takes 6 hours, then that assignment was probably too long, unless that's what I was going for. So I'm going to ask you how long stuff took you a lot. And you can use that as a way to give me feedback about the problems. If you're like, this problem was worded weird or whatever, that's fine. Okay, how to get a good grade in class. Pay attention and ask questions. Don't fall off the bus early. Make sure if you fall off the bus, make sure you get back on it. So if you start getting lost, make sure you stop me and get shored up, because it'll start to go fast and it all builds on itself. So pay attention and ask questions and do the homework. The homework's the most important thing. So that's where I think that you're actually putting in the effort, right? I don't think that anybody's putting in any efforts on the readings. The reason that I don't think that is because I'm telling you not to. But the homeworks I want you to put efforts into. So that's really the effort. So when it comes time to study, make sure that you have already done and understood the homeworks. You can't cram the homeworks. They're hard. So do the homeworks and stay on top of stuff. If you find yourself slipping, please come talk to me so that you don't fall too far behind. That's kind of true for most classes that you take, to be completely honest. Okay, so how have I broken down the grade? So there are several components to the grade. So there's readings, which we'll do a lot, and I'll explain the readings. The readings aren't just reading. There's a question, there's a thing in them. I'll explain the readings in a second. I get stuff out of you doing the readings. Participation, which is just show up basically sober. Homework, there's 2 different kinds of homeworks. There's going to be a homework basically every week, except in the weeks where there's 2. There's a series of numerical assignments that are going to be programming assignments, and I grade those basically by did you put in any effort? Because I understand how many of you are excellent programmers right now? How many of you have never programmed at all? How many of you have done a little bit? All right, cool. That's a good start. So a couple of you have never done it at all. I'm going to work on the assumption that nobody knows anything, just because that way I can catch everything that we need. But the homework, the coding assignments aren't going to be particularly challenging. They're mostly just to get your hands on stuff. And then there are paper homeworks, yeah.
What language will that be in?
Python.
Okay.
I'll explain all of these things in a second. There's 2 midterms, not cumulative, and a final, which is cumulative. This is the first time I've done 2 midterms. I don't know how that's going to work out. I don't know. I don't know how you guys feel about 2 midterms, because on one hand, it's 2 tests. On the other hand, they're half as big. That's why I'm doing it, is because they're half as big. I can ask more questions. Okay, so reading and participation. So the reading summary, I want to know what you read and any questions that you have. And that's actually the thing that I care about. And how long it took you. And that's just so that that's just an error check for me. And feedback from you. But the questions are the important part. That's really what I like the best about the readings. So I'm going to give you a reading assignment. In principle, they're not going to be very long. I'm trying to keep the reading assignments relatively short so that you can read them kind of quick. And then ask questions. That's the important bit. What bits did you not understand about the reading? And some of them are going to be like really long derivations. And if you just write, I didn't understand that big ass derivation, that's totally fine. Or if you don't know what a parsec is and we're halfway through the semester and you're still like, what the hell's a parsec? This is a fine place to ask that question. So this question thing is the question bits on the reading is an important part of this exercise. And then again, tell me how long it took you so that I know. And then participation is another 5% of your grade. And this slide says you'll be randomly called on. I don't usually single out individuals. I usually will ask people en masse, like as a group. But I don't know. From time to time, I might single people out. Okay, so the reading. Don't let it kill you. I'm not looking for detailed summaries. I just want a thumbnail sketch. Unless you're a detailed summary kind of person, if you're the kind of person who sits down with a book, opens it up, and jots down notes, turn that in. Take a cell phone pic of your notes and turn that in. I like to see that because it's good for me to prepare along with you guys. But if that's not what you do to take notes, just jot down the subject headings and like the basic ideas and then ask some questions about whatever you have on your mind about class. Participation is important, mostly because I go faster as I talk, and I'm going to lose you if you guys don't stop me and ask questions. So if I lose you, when I lose you, stop me. Make sure that I don't lose you. We want to keep your brain continuous. Okay, I'm trying something new this semester. I'm trying community questions. That's what these things are for. So I'm going to ask 4-part questions, A, B, C, D, to see what you guys know. And a lot of them are things that I know that you probably don't know, so you're probably going to get them wrong, and that's okay. So it's okay to be wrong. This is something that took me until I was like 40 or 50, or maybe I'll learn it by the time I'm 60, that it's okay to be wrong. So the way these things are going to work is we'll fold these. If everybody could take a second and fold your voter in quarters in the neatest way that you can. That way you can hold up just one. So, yeah. It doesn't have to be super neat. And I'm going to try to color code them, but I couldn't get the color printer to work this morning, so I got a black and white version. This printer took me all friggin' morning. It was the most obnoxious object. Okay, everybody hold up at AA. How does that look? All right. Okay, cool. So part of this is, can I actually see everything? Okay, everybody hold up something random. Just pick one at random. And everybody randomly picks the circle.
It was on the back side of the triangle.
Yeah. Okay, cool. So they're not worth any points, and they're not graded. And I'm going to ask you the same thing twice. So the way it's going to work is I'm going to ask you a question. Oh, did I have that here? Oh, man, I forgot a slide. Okay, so the way this is going to work, I have this somewhere else. The way this is going to work, I'm going to ask you a question, and then I'm going to have you discuss with the people that are next to you. So some of you are, let's see, do we have nice groups of 2, 2, 2, 3, 3, 3, 3? Yeah, so everybody look at the person next to them. If you could talk to the person behind you, and if you could talk to the person behind you. So the people on the sides here, talk to the people behind you. So I'm going to ask you a question, and then I want you guys to discuss what you think the right answer is. And I want everybody to make sure that they have a nice short dialogue. Be polite. And then we'll vote again, and we'll see what the community says. So be polite to your classmates, and it's okay to be wrong. Are the two important things. So let's try one now. So. And this is 2 things. Let's try this as a stunt. But second, I'm super curious about everybody's spatial awareness. So which direction is north? So here, by up, I mean that way. Clearly up is not towards the sky. It's either that way, that way, that way. So A is, let's look at you. A is north is that way. B is north is in front of us. D is that way, and C is behind us. Okay, so I'm going to give everybody 30 seconds to think. And again, it's okay to be wrong. Like you can't see the sun from where you are. It's okay, just guess. Okay, so don't talk yet. Vote. Let's vote first. Okay, ready? Vote first, then talk. Oh, yeah, you're missing one? There you go. Okay, it's kind of all over the place. A lot of C. Okay, now discuss with your friends. So discuss with your friends, and I'll tell you what the right answer is. Now, where do you think it is? Think about the sun. What's that?
We're facing Collins.
The Collins building?
Yeah.
The one that's there?
Right, because that door is facing Collins.
That door is facing the Collins building.
Right. So then, is that yours? I have no idea.
That's all right. Okay. Okay, let's vote again. Everybody vote again. How we do? A little bit more. So that was fun. All right. A little bit more coherent. Not quite perfect, but that's okay. North is that way. Which is C. Which is that way.
Yay.
So it's towards the Collins building, which is why I fixed where you were at, because you were totally true. So when I took my job interview here, everybody good? All right. When I first took my job interview here, I got on an elevator, and that was the first thing that Bill Green asked me. He was like, okay, theorist, which way is north? You don't know where the sky is. Fortunately, I have a good sense of direction, so I did. But anyway, so we'll do that some. We'll do that from time to time, which I think was valuable. I think we had some nice discussion there. Okay, homeworks. There's a bunch of homework, so there's going to be a homework kind of every week. The paper homeworks are long, and they're every other week. The numerical homeworks are short. They're on the off weeks. For the most part, there's some times where the homeworks are on a Monday, because I'll just pull up the schedule and talk to you about it. So again, oh, you be quiet. Again, one of the questions is always going to be, how long did each of these problems take you? And this is a useful litmus for me, not just for your learning, but my teaching. Like if you got through something that I thought was obvious and it took you 7 hours, then maybe I need to make sure I spend more time with that. Okay, late homework. I start grading first thing in the morning when it's due, probably. Sometimes if you're lucky, you can sneak it in at like 8:30 and right before I actually get started. After I start grading, it's 10% off. After I discuss it in class, it's 50% off, but I still want you to do the homework. So if you miss a homework and you sat through it and you watched me go through every derivation, I still want you to do it, because you putting your hands on the stuff is the important part. I don't think I have anything else to say. They're homework problems. They're physics homeworks. So the Python homeworks. So the Python notebooks are all in Jupyter. Has anybody used Jupyter before? Has anybody used Python before? Okay, a couple of you. Python's great because you speak it like a language. It's the barrier to entry is lower than for other languages. And it's a little bit more agile than other languages. So it's a nice first language to learn. It's also the language that I use. So I program supercomputers for the most part, right? But mostly what I use from day to day is Python because it's much easier to work with. So there's 6 short Python exercises, and they're all working at the same thing. The whole purpose of the Python exercise is the relationship between color and temperature. So when you have an object that has a temperature, it also has a color. And you can get the color from that. And this involves what I mean by color, because you don't know that yet, and what I mean by temperature, because we haven't really talked about that either. So the Python homeworks are all kind of around one idea. I assume that nobody's got any programming experience. So if you're like totally freaking out about the possibility of Python programming, don't worry. It's not going to be painful, I promise. And then you can come to office hours and I'll just do it with you. So don't worry about the Python homeworks if you're having code anxiety. They're pretty painless, but they're pretty fun, and they're a useful way for you to put your hands on ideas. Also, you might have noticed the camera. I record everything and I put them on YouTube, and this is so that you can go, when I say something that's way too fast or whatever, you can go watch it again. I try to make sure that I don't have any of your personal information on the YouTube videos, so the camera always points this way. And you can find me, I jumped on the titles. I'm at Dr. Collins, which I'm pretty satisfied about. So you can find me that way. Because I just happened to know that they were handing out labels when they were handing them out, so I jumped on it. Dr. Collins is not an uncommon name. So you can see all the videos. Additionally, you can see Extragalactic Astrophysics, which is the other course that I've taught a lot here. and a hydrodynamics course that I've taught, both of which are great fun. Okay, tests. The midterms are both cumulatively 25%. There's going to be one in September and one in November. I have a schedule up, but I don't know if I trust it. The final will be 35%, and it is Wednesday, December 13th at 12:30 in here. It is cumulatively probably more on the stuff that we hadn't had a test on, but the nature of this material is that it is cumulative. Like I teach you stuff, and then I'm going to teach you stuff using that stuff. Let's see. I think there are 1 or 2 graduate students. I might make graduate students' problems more difficult. I'm actually bad at doing that. So, okay. So, oh, not galaxies. I borrowed from last year's notes. Too many periods. Better. Okay, cool. Yeah. XGal is mostly about galaxies. And that's the course that I do in the spring. Though not next spring, it'll be the following spring. Because of that, I'm going to spend actually 0 time this semester talking about galaxies. So I'm not going to talk about anything bigger than the Milky Way because I have the whole other semester where I talk about everything that's bigger than the Milky Way. Let's see. So reading is 5%. So it's a lot of work and it's not a very big part of your grade. Put in the effort accordingly. But the thing that I want you using that space to be starting your brain, even if it's just an outline of the topics, and asking a question or two. I'm not actually grading anything. So just like it's kind of free form. Homeworks, much less free form. I want you to get the right answer. That says every week. Let's change that. Oh no, actually there's a homework every week. I lied. Because there's a numerical one. There's 2 midterms, and then a final, and then an empty bullet. I don't know what that's for. Okay, so what are we going to talk about? We're going to talk about stars mostly. So we're going to talk about stars in what they look like. We're going to talk about star atmospheres and star interiors. We're going to spend a lot of time on stars because they are some of the most important objects in the universe. They're how we learn anything about outer space. That's not quite true now, but they've been very necessary for us to learn anything about outer space. We're going to learn about planets as well. So we'll talk about the motions of the planets and we'll talk about the individual planets. Haven't decided exactly how much time I'm going to spend on planets. So I have a little thing on black holes that I might be able to do, but I don't actually know how long this is going to take me. So when we get towards around Thanksgiving, I'm going to sort out whether or not we'll spend 2 weeks on planets, which might be fun, or a week on planets and a week on black holes, which also might be fun, but a little bit more scattered. Or I might not have any time and we might cut it all out entirely. And I'll talk about the galaxy probably. So this is what the schedule looks like. So is there a pointer? Do I have a pointer? There's a stick in this room, I'm sure. Because I can't reach all the way up there. I know for a fact there's one back there, but it'll take me 20 minutes to go find it. Where is my? Oh! Sorry, I'm sorry. I rebuilt this laptop like 2 weeks ago because I hate it. I hate this laptop. That'll be a running thing as well. It's also uncooperative. What desktop do you think that's on? Oh, you're over there. I'm sorry. Being an idiot, being stupid in front of people. Okay, let's try this again. So So tomorrow we're going to talk about coordinates. So this is what we're doing day by day, and this is the readings that are due, and this is when the homeworks are due. N 1 through 6 are the numerical homeworks, and P 1 through whatever are the paper homeworks. So so this is in the syllabus, but I'm going to tweak it as things go. The link you can find on the side. So if you open up the syllabus, you can find this link. It's also on the front page of Canvas. So there's a link right to this schedule so that you can see what's coming up. So the readings, I've clarified 2A a little bit. That's the first half of chapter 2. So the readings 1.3 and 3.1 are due Wednesday, and then chapter 2 is due Friday. The first 2 readings, if you miss the reading, that's okay. It's not that big of a deal. But chapter 2 starts to get hard, so I really want to please make sure that you get a copy of the book and read that section beforehand, because it's. I don't mean to say that it's like spooky hard, and I think that it's stuff that you've seen already, but the math gets serious. So I want you to look at it beforehand. So we'll first talk about coordinates, and then we'll talk about Kepler and Newton. We'll spend 2 days on Kepler and Newton and talk about how planets move around. There's a numerical homework that's due Friday, and that numerical homework is very simple. Download Anaconda, fire up the first homework set, read it, and turn it back in. You don't have to do anything, but doing all those things is maybe a headache. It's usually pretty straightforward, but every now and again you stub your toe on something. So the first numerical assignment is just download Anaconda, run the first notebook, tell me that you did that. So it's not painful, but the first paper homework will be due next Friday. I will post it before this Friday. I will always give you a week for paper homeworks. Okay, so we'll do Kepler and Newton, and then we'll talk about distributions. So that's just math. I'm just going to talk about math for a minute, but it's math that I think that nobody ever sits down and says this until you've taken advanced probability and statistics. But I can't wait for that. I need it now. So we'll go through that. And then we'll go through magnitudes and black bodies. Have you guys seen the black body radiation before? How many people have seen black body radiation somewhere? I have never heard of black body radiation before. Okay, great. I'll spend a lot of time talking about that because it's very important. Black body radiation is, to be short, it's the radiation of temperature. So if you've got an object that has some temperature, the thermal radiation gives you a black body. So we'll talk a lot about that in detail. And then we'll talk about a little bit of quantum mechanics and how does matter interact with light, because that's important. Then we'll talk about telescopes. I think I'm going to do 2 days for that because there's a lot of cool telescopes. And then the book is from 2007. The last 15 years have really been pretty explosive in terms of astrophysics. So we'll talk about the newer telescopes like JWST, which isn't in this book. It might be mentioned because I've been hearing about JWST since I was younger than you are, which was a while ago. JWST's been in the pipeline for a long time. So we'll talk about that. Then we'll talk about binary stars, which have a particularly important place in outer space. First, because most stars are binaries. And second, because they're very, very useful. I'll show you why. And then we'll have a midterm. So the first midterm is just going to cover Kepler and Newton, telescopes, binaries, black bodies. And then we'll talk about spectra. And then we'll talk about how do stars look. So we'll talk about the spectra. We'll talk about what a spectrum is. We'll talk about the HR diagram, which is an incredibly important picture of stars and how stars are related. And then we'll spend a couple days talking about stellar atmospheres. Seems like a long time to talk about the atmosphere, but there's a lot of really great physics that you can use that vehicle to talk about. So we're going to talk about mostly how do photons go through matter? How does light go through matter? Then we'll talk about stellar interiors. So that's a little bit of plasma physics, really a lot of hydrodynamics. So a star is just a big ball of stuff. When I look at a star, what I see is the temperature, and then so the radiation comes off the surface because it has a temperature, and then it has to pass through the atmosphere. And the atmosphere jacks up what the light looks like. So we need to study both things. We need to study the sphere of the sun, and then we'll study the atmosphere. Then we'll study some stellar evolution and then how stars die. So what happens when a star runs out of juice. Then we'll have the second midterm. Then we'll talk about star formation. Unless I decide to just stick star formation on this midterm if like things are going quick. I don't know. Some of this might move around a little bit. Then we'll talk about planets, and then we'll talk about the final. So that's what the semester looks like, kind of in a nutshell. Sign-in sheet. I forgot to do this already. I think everybody's supposed to sign in for the first day, right?
Yes.
So if everybody could sign in that one, so that I don't drop you. And I'm not gonna lie to you, man. I forget to push that button that everybody was here every year, every semester, and it has never been a problem. So I feel like I'm supposed to do this, but I forget to look at it. Okay. Does anybody have any questions about logistics? Well, actually, let me pull up.
So what's gonna be like the balance between like math and conceptual stuff?
It's about 80% math and about 80% conceptual. And the other 20% is just annoying algebra.
Okay.
But some of both. So there's a lot of conceptual, but there's plenty of math. And the math is, I don't know, will involve calculus. It probably won't be, especially at the beginning, won't be too much worse than what you saw in 2048, 2049.
Okay.
Also, I recognize that you guys have all seen calculus, but you're not that great at it yet. And that's because you just learned it like recently, right? So I understand that you've got to learn some of that too. I don't mean that in a snarky way at all. Like, this is an educational process. We're all coming up the mountain of knowledge. So it's the things that I think that you might need help with or whatnot. Or if you get to some place and you're like, I forget how calculus works, we could talk about that too. But there's plenty of math. Okay, let us put some numbers on things. Let's see, and I got 20 minutes left. Okay, cool. I also have, this is the first time I've taught a 50-minute lecture. I have absolutely no idea how long 50 minutes is. I really have a very good idea of how long 75 minutes is. So today I'm going to talk a little bit. Oops, wrong slide deck. That one has math in it. We don't want that one yet. I don't want any math today. Okay. Oh, that's everything. Let's zip backwards. Oh, it's not a draft version anymore. I'm just gonna talk about where we are and how big things are, just to get everybody kind of on the same footing about what are we trying to do in this class. So we'll start at the Earth, and then we'll talk about the solar system, and then we'll just start talking about bigger and bigger things until we finally talk about everything. So let's start at Tallahassee. Here's Tallahassee. It is 800 meters. Yeah. I will try to get them up before. They will always go up. Sometimes I will flake, and you'll have to ask. So if they're not up, just shoot me an email, and I'll put them up. I'm going to try to get them done before class, but I'm also writing them as I go. So I will try. And if you could drop me an email at some point in time and say, hey, please post slides before class, that'd be handy, because I am not always in that habit. But it's a good habit to be in, so I can try. So it's about 800 meters between here and Momo's. Does everybody know how to get to Momo's from here? It's one of the most important places. The one on Tennessee is closer.
Okay.
You know, the one on Pensacola is kind of a hike, right? I've never been to the one on Pensacola. I just learned about it recently.
Fun.
Is it good?
Yeah, there's posters like everywhere.
Oh, dope.
And it's cool lighting. It's groovy.
Oh, nice. My older son just started going to Sale, so I drive past it all the time because Sale's right over there. Okay, so what is that? So I'm going to put up for everything here, I'm going to put up 3 units. I'm going to put up meters, astronomical units, and parsecs. The meter is something that I have comfort with, right? And if you don't like meter, you can say feet and just multiply everything by 3. It's the same idea, right? So a meter is, about yay big. 800 of them between me and Momo's, me and my big ass slice of pie. This is 10 to the minus 9 astronomical units and 10 to the minus 14 parsecs. Does anybody here know what an astronomical unit is? I know what an astronomical unit is. I have no idea what an astronomical unit is. Somewhere in the middle. All right.
I just assumed it's incomprehensible.
No, it's totally comprehensible. Okay, I'm gonna draw a picture.
It's too big.
Yeah, it's too large.
It's too big, I can't comprehend it.
No, you just gotta think logarithmically. You can comprehend anything of any size. You just have to think logarithmically. Okay, so here's the sun, and here's the Earth, right? The distance between the Earth and the sun is, on average, 1 AU. There's some specifics about the distances. I drew this circle. That's not a circle, but it's round enough. Really, what kind of shape are they? They should be ellipses. I'll tell you that tomorrow. The distance between the Earth and the sun is 1 astronomical unit. This is really useful because it's like the biggest ruler that we actually can put our hands on, right? Because we're sitting on it. If you want to move your measurement device by 1 astronomical unit, you just have to wait 3 months, and it goes over here. Now that is 1 astronomical unit away. Or 6 months, and then you're 2 astronomical units away. Now this is useful because, I should have put the parallax, anyway. I'm realizing, you know how I said that this is my first time through these slides, I should have described them in a different order. So everybody hold up your thumb, and I'll stand in the middle. Everybody hold up their thumb and cover me up with your left eye. Right? Okay, so now I should not be able to see anyone's left eye. Right? Okay, now hold your thumb there and switch eyes. Now look at me through your right eye. Now, how far away am I? Now, if you could actually do all the math, that's all you need to do to figure out how far away something is. You can measure how far, I'll talk about this more in detail. You measure how far it moves perceptually, and you can use geometry to figure out how far away it is. So what that looks like, if we're using the Earth, if you're using your arm, here's your head, and here's your nose, here's your arm, and here's an object. Let's put this object here. So I have 2 eyes. So if it's covered up with 1 eye, but not the other, then I know this distance, because I know how long my arm is. I know this distance because I know how far my eyes are. So I know this distance because of similar triangles, because you can measure how far it jumps. I'll talk about this in detail again in a second. But does everybody get and have a basic idea of what I'm talking about? You move, a thing you're looking at moves too. You can use that and geometry to tell how far away it is. That's all I need right now. Because what I'm going to say is what we do with this, here's the Earth again, moving around the sun. Here's the Earth. Here's the Earth. This distance is 2 AU. If I'm looking at a star here, and then there's a background star way up there, we'll call that background star at infinity. I can see it here in June, and then here in January. This moves by a distance. If this distance is 1 arc second, which is a fraction of a degree, this distance is 2 AU, then this distance is 2, because we have 2 AU, parsecs. So a parsec is this very important unit when you're talking about outer space, because it's the distance unit that we can put our hands on the most easily after the AU. So we go around the planet once and the sun once and the thing moves, and then I know that thing's this parsec across. Parsec stands for parallax arc second. So a second of arc is 1/60th of a minute of arc, and a minute of arc is 1/60th of a degree. I'll say that again tomorrow. But a parallax arc second. So this is about 3 light years. Right? So the 3 kind of key measurement sizes that we use as astronomers are meters. That's actually not a lie. We use centimeters for reasons that I'll explain later. Because MKS, the System International, is stupid and broken. And we should use CGS because it's not stupid. But that's a side tangent. So we got these 3 units. So I'm just going to walk through the universe and talk about how these things, how big are these things. So a meter is like half a me. An AU is like the size of the solar system. And a parsec is like kind of where you can extrapolate to from the solar system. So let's see, a femtoparsec. Femto means 10 to the minus 15, right? A femtoparsec is about here to the Keene building, which pleases me enormously. Because, okay, femto is the tiny prefix, right? A femtometer is like 10 to the minus 15 meters. So we are a tiny thing if what you're talking about is a parsec. Here's the Earth. There is Tallahassee in the northern hemisphere. The size of the Earth is 1 million meters. So really, right away, we're at very large for a meter. It's 10 to the minus 5 astronomical units and 10 to the minus 10 parsecs. So the whole planet is very small if you're a parsec. I will spend some time, I will spend a little bit of time talking about the Earth and its interior. I want to spend more time talking about the solar system because there's a lot of stuff in the solar system. So the solar system has the sun, which is huge and in the center. It's got 4 rock planets. It's got 4 gas planets. It's got 9 dwarf planets, probably. There might be more than that. They're hard to see. So this is where, so everybody complains about Pluto getting demoted, but really it's not really how it worked. We realized that there were all these other things that really aren't planets, and Pluto's one of those things. There's lots of asteroids. There's like 1 million little objects. There are 1 million numbered objects in the solar system, like 1.6 million objects that people have measured. There's a lot of plasma, which is fascinating. And let's see. So the size scale. So the radius of an AU is 1.5 times 10 to the 11 meters. That's a lot. The solar system scale is like an AU. The size of an AU in parsecs is 4 times 10 to the minus 6 parsecs. Pluto is everybody's favorite dwarf planet, is at about 40 AU from the center. And Voyager, which is the furthest thing that we've shot out of the solar system, is 141 astronomical units, which is mind-blowing to me. We go out a little bit further than that, and we get out to the Oort cloud and the Kuiper belt. So the Oort cloud, so we've got our things, and these are the things that we can see. And then there's all of the, forgot to have the power. So the Oort cloud is this big cloud of stuff that's centered on the sun. It's like all of the crap in outer space that's attracted to the sun, but not so bound to the sun that we can really see it. And we don't actually know how big the Oort cloud or the Kuiper belt are. So the Kuiper belt is kind of is a little bit smaller than the Oort cloud, but they're just big. It's a huge cloud of stuff that probably stretches out to about a parsec. So a parsec, remember, is about 3 light years. And there's this cloud of little stuff. There might be another major planet. Might be. I don't know if there actually is, but there's some very compelling papers that said there might be another major planet, but nobody's seen it yet, so we'll see. Don't actually take that as a measurement. There's only 8 planets. The next closest star to us is called Alpha Centauri. So there's really nothing between, there's one brown dwarf between us and Alpha Centauri. But there's really nothing there for about 1.3 parsecs. So that's how many light years? It's like 4 and change light years. The distance is 10 to the 16 meters. Now we're in the large scale, so this is where you have to start thinking logarithmically. So you've got to start thinking in the exponent. 10 to the 16 meters. 10 to the 6 AU is the distance to the next star. So Alpha Centauri is a triple system, which is neat. Most stars are binaries, and a lot of binaries are triples. It's got 3 parts. Rigel Centaurus, or Alpha Cent A, it's almost always Alpha Cent A, Alpha Cent B, or Ptolemy, and Proxima Centauri, which everybody calls Proxima Centauri, because it is, so Alpha Centauri is kind of awesome. I'm going to tell you later that a triple system is completely unstable, but here is one. The way this works is Alpha Centauri A and B are a little binary system, and they're very close together. And Alpha Centauri C is orbiting those two guys way out at a big radius. So that big radius actually makes it really close to us. And it has a planet in the habitable zone, which is kind of awesome. I haven't told you what the habitable zone is, but it sounds pretty nice, right? It sounds like a place you'd want to be. It sounds habitable. But the planet is a really ultraviolet planet. So, or the star is an ultraviolet star. So it would be awful. So I don't think there's life there, but there might be. There might be. We just need to get a thing there. Okay. So that's Alpha Centauri. That's our next neighbor. And that's at a distance of 1 parsec. That kind of sets the scale of how far away things are in the galaxy. A parsec is about how far away stuff is. This is, I already went through this. So if we go outside of Alpha Centauri, we live in this fascinating hole in the galaxy called the local bubble. The local bubble is about 1,000 parsecs across, or 10 to the 19 meters, or 10 to the 8 astronomical units. And it's basically empty space. There's really nothing there. So I tell people a lot that empty space has a lot of cool stuff in it. But really, the local bubble is kind of empty. It's kind of weird, which is nice. It's awesome because that means we can see. It means there's not big clouds of dust in a way from seeing outside the galaxy. So at the edge of the local bubble is a thing called the Gould Belt. And it's a ring. So this is a map of the Gould Belt, and this is one of the objects in the Gould Belt. So has everybody seen this before? I have seen this image before? All right, so most people have seen this Pillars of Creation. So this is the Pillars of Creation, and this is the JWST image of it. Hubble took a very famous image of this cloud sometime in the 90s, early 2000s. But this is a big cloud that's actively forming stars as we speak, and it doesn't really show up very well on this projector. It's not great. It's a gorgeous image. So this is one of the objects that's in this Gould Belt. So the sun is here, and the Gould Belt is this ring of molecular clouds and star-forming regions. So all of these objects that are labeled here are star-forming regions, or molecular clouds, which are basically the same thing. All of these molecular clouds are actively forming stars, which is weird. So we've got all of this. So the universe, the part of the galaxy that we live in, has kind of us and then nothing, and all of this cool activity. Like there's all this incredible stuff that's happening that's really right here. I say it's 1,000 parsecs away, and that seems like a big number, but it's very close. So that's very cool. So I like the Gould Belt a lot. It's one of my favorite parts of the galaxy. So this is the Milky Way. This is where we are. So the Milky Way is a spiral galaxy, and it has these arms. Spiral galaxies have arms that are density waves that are kind of like ripples in a pool, except the whole thing's kind of rotating, and so and the sound speed changes as you go out. So they don't stay round; they get spirally, but they're like ripples. They're waves. You got these really major arms, and this is an artist's rendition. They use radio telescopes to map out where their arms are, and then draw this picture based on what they each look like. So the center of the galaxy is an overdensity of stars, and it's a big bar. It's elongated. It's shaped like a tube. And we are about 8 kiloparsecs away from the center of the galaxy. This is a difficult thing to measure because you got to sort out what the center of the galaxy is. Okay, I got 1 minute left, and I'm just going to zip out through the rest of the galaxy, or the rest of the universe. So the galaxy, so we live in the Milky Way galaxy, which we're at 8 kiloparsecs. The whole thing is about 25 kiloparsecs in radius. Surrounded by us we live in this local group. The local group contains 3 major spiral galaxies, us, Andromeda, and the Trapezium. And they're all big spiral galaxies that look like that guy. Well, that one looks like that one. That's Andromeda. There's also a lot of other dwarf galaxies. So here in this image, this is an image from Chile, and you can see this guy, it's not part of our galaxy, and this guy is not part of our galaxy. And that's really cool. Those things are really, really, really far away. Everything else you see is within the galaxy, and most of it is actually really close. Most of the stars that you see are about at the Gould belt. That's where most of the stars are. To really see stuff that's super far away, you have to get very dark or outer space. Okay, so that's the local group. The local group is 3 big spiral galaxies and a bunch of little tiny galaxies. The large and the small Magellanic Clouds are orbiting us. So the large Magellanic Cloud is 50 kiloparsecs away, so 50,000 light years away. So that's the distance to the next like little thing that's just hanging on to the dwarf galaxy. This is like, sorry, that analogy doesn't work. Yeah.
How big is the cloud?
Which cloud?
The small.
The small one, I don't remember how big the small Magellanic Clouds is. So the actual mass of the clouds are like 10 to the 10 solar masses, whereas the Milky Way is about 10 to the 12. So they're about 1% of the size. And Andromeda is the next big. Andromeda is maybe a little bit bigger than the Milky Way. It's at a distance of 700 kiloparsecs. So that's the local neighborhood. So that's just our neighborhood. Outside of that, we live in this supercluster called Laniakea. And it's about 150 million parsecs across. And I stopped putting the other numbers because you never deal with parsecs or AU when you're talking about some things the size of a supercluster. So we live in this supercluster, and then my one last slide, now I'm 2 minutes over, the radius of the actual universe is about 10 to the 10 parsecs. That's everything. It's everything that matters. It's actually infinite, but it also is finite enough that we can talk about the edge of it. So okay, that's everything. The reading due. Let me know how it goes. I'll talk to you guys on Wednesday.